In the second half of today's lesson, we'll be solving a few word problems. So these are similar to what you'll end up seeing. So let's take a look at this first one here. It talks about an Olympic diver is competing for a medal. His height in feet above the water can be modeled by this function. So this f of x is the same thing as just saying y. It means the same exact thing. It's just a different notation. It's called function notation. And so we see what this ends up looking like. So the graph of this, since it's a negative 3x squared, I know it ends up opening down. So it opens down. So that gives me an idea about what I'm trying to do here. And it kind of makes sense. The diver starts at this platform. And since if I go ahead and take out these x's and set them equal to 0, this is the y-intercept. So this is where he starts. It's the y-intercept. Or in this case, it's the initial height of the diver. So that means he's starting 24 feet up. So he's way up here. Now think about what he's going to do. He's not going to just drop straight down. He's going to jump up in the air, and then he's going to come back down. So let's see what they want. X represents the time in seconds. That's what it says here. That's the x-axis. And then the y-axis is going to end up being the height. That's what it says right here. So x is time in seconds after he begins the dive. Graph the function, then find how long it takes the diver to reach the water. So eventually, he's going to end up coming down and he's going to hit the water, and that's when his height will be 0, is when he hits the water. We want to find the time. Well, what we're going to do is we're going to graph this function to solve this problem. So there are other ways to do it, but that's the method that we're working on in this section. So we'll start with our axis of symmetry formula, negative b over 2a. And so we take our b value, which is 6, and it's the opposite of 6, over 2 times a, which is negative 3. And so that makes negative 6 over negative 6, which just makes 1. So 1 is the number that goes out for these x's. That'll give us our y value. So negative 3 times by 1 squared plus 6 times by 1, and then plus 24. So we go ahead and do some work there. Negative 3 times by 1 obviously gives me negative 3. And remember what I've talked about a bunch of times. This b term here, 6 times 1 is 6. These two numbers should be opposite in sign, one double the other, and that's the case here. So I'll just carry down these numbers here, and I do some work here, and I end up with 3 plus 24 makes 27. So there's our y value. So the vertex is 127. So if I go over 1, and I go up 27 spaces, right there is the vertex. So that means that this graph is symmetrical about this vertical line that I'm putting in place right here. And so what that tells us, since I've got the y-intercept already, I've got another point opposite that y-intercept, the same distance from it. So it'd be right there. So after 2 seconds, that means that he would end up being back to where he started at the 24 feet. Well, let's continue this down. We want to find out when he'll hit the water. And so we're going to go ahead and try this method of using that parent graph. So y equals the opposite of 3 times by x squared. Notice that if you plug in a 1 and you square it, or negative 1 and you square it, you end up getting 1. 1 times by negative 3 gives us negative 3. And that's what we did here. You see, if you go over one space is really 2 here because they're broken by halves. 1 space over, 3 spaces down gets you to this point. 1 space to the left, 3 spaces down gets to that point. See, it's symmetrical. And so if you plug in a 2 and we square that, we end up getting 4. 4 times by negative 3 gives us negative 12. So I end up having to go down 12 spaces. So over 2. So 1, 2, down 12. So there's down 12 spaces. If I subtract 12 from 27, I end up with 15. So it would be right here, it looks like. Oops. Let's see, right there. Yep, that would be it. So I'm almost there. Let's go another time. Let's go ahead and put a 3 in there. Plus or minus 3. Square it, you get 9. 9 times by negative 3. Hey, look at that. You get 27. Negative 27. So I have to go down 27. So over 3 seconds. Over 3 from this point here. So it's 1, 2, 3, down 27, puts me right on the x-axis, and exactly what I wanted. I wanted that number, 4 seconds. So that's how long it takes. It's going to end up being 4 seconds until the diver hits the water. And so just using that graph helped me figure out that amount. So let's take a look at the next one here. Tasha kicks a soccer ball during a game. The height of the ball in feet can be modeled by this function. Again, this f of x, same thing as just saying y. Well, here there's no c term, so no c term. So that means that the ball starts on the ground. So that tells us that the initial height, so let me spell that right here, fix that real quick. So the initial height ends up being 0. So we'll say initial height equals 0 because there's no c term. So that means the graph starts right there at the origin. And so that's something we know. Let's go ahead and write in other things that we can, or read the rest of the problem, I guess, where x is the time in seconds, same sort of thing. So we dealt with before, x is in seconds. And it looks like the y-axis is in feet. And we're supposed to graph the function, find the maximum height. So how high did the ball end up going? So that's the y-axis that we want. And then how long it takes the ball to reach the maximum height. So that's what they want to know. So that's the time to the maximum height. So what we want is the axis of symmetry to start with, negative b over 2a. And this is actually going to give us the second question. It's going to give us how long it takes the ball to reach that maximum height. So negative b. So the b term is negative, or is 48, so it's the opposite of that, so negative 48 over 2 times negative 16. So that makes negative 48 over negative 32, which we can reduce. I see that 16 goes into these numbers, and that reduces all the way to 3 halves. So 3 halves, well, that would mean x is 1.5. So 1.5 seconds to maximum height. That's the time it takes. That's part of the question there that they're asking. So 1.5 seconds. That's right along this line right here. So I'm going to draw a little dash line. That's the axis of symmetry. So it's going to be somewhere along there. Now we have to find out how high up it goes. So that's the y value. So we just plug in the numbers, that 1.5 that we have. Now, instead of 1.5, let's use 3 halves. It makes it a lot easier, and you'll see it as I do this problem. So plus 48 times by 3 halves. So remember what I had talked about before. Once we find these numbers, one's going to be negative, one's going to be positive, and one's double the other. So it makes the problem go a little bit faster, and you'll see how. Negative 16 times 3 halves squared. 3 squared makes 9. 2 squared makes 4. All right, so I'm multiplying those. Over here, I can do some reducing. 2 goes into 48 24 times, and I can multiply those. So that makes it 12. 72 is what I end up with there. Here, 4 goes into 16 4 times. Multiply here, I get negative 36. So notice that they're opposite signs, and one is double the other. So you're just subtracting the two numbers. And whatever the smaller value is what the number is going to be, 36 in this case. So that means that the height is 36 feet up. That's the maximum height. So if you go over 1.5 up 36, that's the point. So that's how high it ends up going. So it ends up going way up here, really steep, and it went up that 36 feet, and then it's going to come straight back down. So it's going to end up hitting the ground. It took 1.5 seconds to go up. It's going to take 1.5 seconds to come back down. So it's going to come down right at the 3-second mark. And that's what the graph will end up looking like. Something like that, except without this little hitch inside. It's going to be symmetrical on both sides. And so there it is. Those are the types of problems you'll end up seeing on tonight's homework. Good luck.